Mercedes-Benz cars and vans, part of the world's leading premium luxury automotive brand, has long been known for pushing the boundaries of engineering. Now, their latest project could redefine everything we know about the auto industry. With a remarkably strong product lineup driving success in the first half of the year, Mercedes is making headlines once again, but not for joining the race toward electrification. Instead, they may have just thrown the industry's biggest curveball. In a bold move that challenges the global momentum toward electric vehicles, EVs, the CEO of Mercedes-Benz recently claimed their new engine could disrupt the EV market entirely. As most automakers shift away from combustion engines in favor of battery-powered alternatives, Mercedes is taking a radically different path, one that could reshape the future of transportation. For years, EVs have been positioned as the inevitable future, with traditional engines labeled obsolete. But what if that narrative is about to change? What if Mercedes has quietly developed a combustion engine so advanced, so efficient, that it makes full electrification seem premature? This isn't just about nostalgia for the sound of a roaring engine, it's about engineering brilliance and pushing the boundaries of combustion technology. To understand the significance of this development, we must first look back at the legacy that brought Mercedes to this point. As one of the most iconic names in the automotive world, Mercedes-Benz has always embodied performance, luxury, and innovation. The company's roots date back to the late 19th century, when visionary engineers Carl Benz and Gottlieb Daimler laid the groundwork for what would become one of the most influential automakers in history. Officially established in 1926, Mercedes-Benz's journey, from inventing the first automobile to dominating both motorsports and the luxury market, reflects a relentless commitment to innovation that continues to drive the brand forward today. The history of Mercedes-Benz stretches back well before its official formation. Carl Benz is widely credited with inventing the first gasoline-powered automobile in 1886 with the Benz patent motorwagen, a lightweight vehicle featuring a single-cylinder engine and a basic steering mechanism. Around the same time, Gottlieb Daimler and Wilhelm Maybach were independently developing a high-speed gasoline engine, which they later installed in a carriage, creating their own version of a motorized vehicle. Though the inventors initially worked separately, their paths converged in 1926 when the companies founded by Benz and Daimler merged to form Mercedes-Benz. The brand took its name from Daimler's popular Mercedes models, named after the daughter of Emil Jelinek, a key investor and business partner. From that point on, Mercedes-Benz established itself as a pioneer in automotive innovation, continually pushing the limits of technology and design. Beyond road cars, the company built a formidable legacy in motorsport, using racing as a testbed for cutting-edge engineering. In the early 1900s, Mercedes-powered vehicles began winning major races such as the Gordon Bennett Cup. By the 1930s, Mercedes-Benz had become a dominant force in Grand Prix racing, particularly with its legendary Silver Arrows, sleek, aerodynamic race cars like the Mercedes-Benz W125, which debuted in 1937 with a supercharged inline-8 engine producing 646 horsepower. These vehicles became symbols of German engineering excellence, breaking records and winning championships. However, following the tragic 1955 Sierra Leone's Mans disaster, where a Mercedes 300 SLR crashed and resulted in the deaths of over 80 spectators, the company withdrew from motorsport for several decades. Mercedes-Benz eventually returned to racing with renewed vigor, culminating in the dominant performance of the Mercedes-AMG Petronas Formula One team in the 21st century. With renowned drivers such as Lewis Hamilton and Nico Rosberg, the team secured 8 consecutive Constructors' Championships from 2014 to 2021, solidifying its place as one of the most successful teams in Formula One history. Mercedes-Benz's involvement in Formula One has consistently driven technological advancements, particularly in areas such as hybrid power units, aerodynamics, and material science, many of which eventually make their way into its road cars. Renowned for its legacy of luxury, the brand has continually set new benchmarks for comfort, safety, and performance. A prime example is the S-Class, first introduced as the W116 in 1972, which redefined the luxury automobile segment. The S-Class pioneered features such as anti-lock braking systems, ABS, airbags, and later innovations like adaptive cruise control and semi-autonomous driving technologies, setting a new standard for high-end vehicles. Mercedes-Benz's performance credentials were further enhanced by AMG, a company originally founded in the 1960s as an independent tuner specializing in racing modifications for Mercedes cars. Eventually brought in-house, AMG pushed the boundaries of performance with iconic models like the 1980s E-Class Hammer and the modern-day Mercedes-AMG GT, blending refined luxury with extreme performance. The brand has also played a pivotal role in advancing automotive safety. As early as the 1950s, Mercedes was one of the first manufacturers to introduce crumple zones, designed to absorb crash energy and protect passengers. This commitment continued with the introduction of the pre-safe system in the early 2000s, which anticipates collisions and takes proactive measures, such as tightening seatbelts and adjusting seating positions, to mitigate injury. In terms of innovation, Mercedes-Benz has long been at the forefront. It was instrumental in popularizing diesel-powered passenger cars, launching the first production diesel vehicle, the 260D, in 1936. More recently, the company has become a leader in electrification and hybrid technologies. While initially cautious about fully embracing electric vehicles, Mercedes has since invested heavily in battery development and alternative fuels. The EQ lineup underscores the brand's commitment to sustainability, while ongoing research into synthetic fuels and hydrogen technology shows that it is not yet ready to fully abandon internal combustion engines. Additionally, Mercedes-Benz continues to push the envelope in autonomous driving. Both the S-Class and the EQS are equipped with some of the most advanced driver assistance systems available today, steadily moving the brand closer to full self-driving capabilities with each new generation. Mercedes-Benz has consistently remained at the forefront of the automotive industry by integrating advanced artificial intelligence, connectivity, and automation into its vehicles. This relentless pursuit of innovation is deeply rooted in the company's heritage, particularly in the development of its engines, one of the primary factors behind Mercedes-Benz's enduring dominance. The legacy began with Carl Benz in 1879 when he engineered his first stationary gasoline engine, a one-cylinder, two-stroke machine. Just a few years later, in 1885, he revolutionized transportation with the creation of the world's first self-propelled automobile, the Benz patent motorwagen. Simultaneously, Gottlieb Daimler and Wilhelm Maybach were pioneering their own gasoline-powered engines, culminating in the transformation of a horse-drawn carriage into a motorized vehicle in 1886. These parallel innovations didn't merely establish Mercedes-Benz as a key player, they laid the very foundation for the modern internal combustion engine. By the early 20th century, Mercedes was refining inline-6 and inline-8 engines, configurations that became synonymous with smoothness and power. However, the 1960s marked a new era when Mercedes-Benz revolutionized luxury performance with the introduction of the M100 V8 engine. Debuting in the Mercedes-Benz 600 Pullman, this 6.3-liter V8 delivered massive, yet whisper-quiet power, earning admiration from world leaders and celebrities alike. As technology advanced, so did Mercedes-Benz's engine design. The M156, the first engine developed entirely by Mercedes-AMG, was a milestone. This naturally aspirated 6.2-liter V8, produced between 2006 and 2015, became legendary for its fierce acceleration and the iconic AMG roar. For those seeking even greater performance, the M275 engine delivered. This twin-turbocharged 6.0-liter V12 exemplified luxury and power, turning high-performance Mercedes sedans and coupés into true Autobahn missiles. Yet not all of Mercedes-Benz's legendary engines focused solely on speed. In the 1970s, the OM617 diesel engine demonstrated the brand's commitment to endurance and reliability. This 3.0-liter, 5-cylinder diesel became renowned for its durability, frequently exceeding 500,000 miles with proper care, and served as a dependable workhorse for countless vehicles around the world. Through every era, Mercedes-Benz has continued to push the limits of what automotive engineering can achieve. Mercedes-Benz taxis around the world earned a reputation for having some of the most indestructible engines ever built. However, as global priorities shifted toward fuel efficiency and reduced emissions, Mercedes had to evolve. The era of large, naturally aspirated engines began to fade, making way for turbocharging. By compressing more air into the combustion chamber, turbocharged engines offered the potential to produce equal or greater power while consuming less fuel. Mercedes embraced this shift, developing turbocharged powertrains that delivered smoother and more responsive performance without compromising on power. In the mid-2000s, Mercedes introduced Blue TEC diesel technology, a major step forward in reducing nitrogen oxide emissions and making diesel engines cleaner. These engines featured advanced exhaust treatment systems to meet increasingly strict environmental regulations while maintaining the inherent fuel economy and torque benefits of diesel power. Understanding that true efficiency required more than just cleaner combustion, Mercedes turned to hybridization. By integrating electric motors with traditional gasoline or diesel engines, they developed hybrid systems that not only reduced emissions and improved fuel economy but also preserved the brand's hallmark driving dynamics. Innovation has always been at the heart of Mercedes-Benz. From the pioneering days of Carl Benz to the raw power of AMG performance engines, and now the modern drive toward sustainable mobility, the company has continuously pushed the boundaries of engine technology. Yet, Mercedes' most transformative leap wasn't merely about improving combustion engines, it was about reimagining the future of powertrains entirely. This shift led to the development of a revolutionary engine that the current CEO claims could potentially disrupt the entire EV industry. We'll explore that in greater detail soon, as the secrets to Mercedes' success are embedded in their cutting-edge hybrid and all-electric vehicle technologies. The company's dedication to innovation in this area dates back further than many realize. As early as 1906, Mercedes introduced the Mixed, a hybrid vehicle that combined a gasoline engine with a dynamo to generate electric power. Fast forward to the late 1990s and early 2000s, Mercedes revisited hybrid technology, experimenting with new systems to enhance fuel efficiency and meet the demands of a changing automotive landscape. In an effort to reduce emissions, early initiatives by Mercedes-Benz laid the groundwork for a transformative shift in the automotive industry. Recognizing the potential of integrating internal combustion engines with electric motors, the company introduced its EQ power line, a significant step toward plug-in hybrid technology. This initiative aimed to bridge the gap between conventional gasoline-powered vehicles and fully electric models, offering drivers the convenience of electric driving for shorter trips, along with the reassurance of a combustion engine for longer journeys. Building on the success of EQ Power, Mercedes-Benz took a bold step by launching the EQ brand, signaling a firm commitment to full electrification. The debut of the EQC in 2018 marked the brand's first all-electric model, showcasing the company's dedication to sustainable luxury. Subsequent models like the EQS and EQA further cemented Mercedes-Benz's presence in the growing electric vehicle market. Despite these advancements, the company approached full electrification with caution. Concerns over battery technology, charging infrastructure, and market readiness influenced their strategy. Rather than executing an immediate shift to electric vehicles, Mercedes-Benz focused on refining its hybrid systems, believing that a gradual transition would best serve its customers and preserve the brand's legacy of reliability. This measured approach received mixed reactions. While some industry experts praised the company for maintaining high standards and offering flexible options during a period of technological evolution, others questioned whether the conservative pace allowed competitors, particularly Tesla and BMW, to gain a competitive edge in the emerging EV landscape. Nonetheless, Mercedes-Benz's legacy in automotive innovation remained strong. In 2016, the company underscored its commitment to electrification by founding Mercedes-Benz Energy, a subsidiary dedicated to battery storage solutions. This move highlighted a broader strategic vision. Electrification was not limited to producing electric vehicles, but part of a comprehensive plan to reshape the future of mobility. In addition to its focus on energy management and sustainable mobility, Mercedes-Benz made a significant move in 2016 at the Paris Motor Show by unveiling the Generation EQ concept vehicle, marking the official debut of its all-electric sub-brand, Mercedes EQ. The company outlined an ambitious roadmap, aiming to launch at least 10 EQ models by 2022 and to ensure that the majority of its vehicles would be electrified in some form by 2030. In 2018, Mercedes introduced its first fully electric production model under the EQ banner, the EQC. This luxury SUV was designed to compete directly with Tesla's Model X and other high-end electric vehicles. Equipped with an 80 kWh battery, a dual-motor all-wheel drive system delivering 402 horsepower, and a range of approximately 259 miles, the EQC was praised for its refinement, build quality, and comfort. However, it faced criticism for its relatively limited range and slow charging capabilities compared to Tesla. Undeterred, Mercedes continued to expand its electric lineup. The EQA and EQB targeted the compact SUV market, while the EQS emerged as the brand's all-electric luxury flagship, showcasing advanced technology and achieving an industry-leading drag coefficient of 0.20, making it one of the most aerodynamic production cars ever built. Building on this momentum, Mercedes launched the EQE as an electric counterpart to the E-Class and revealed the EQG, an electrified version of the iconic G-Class. Despite these advancements, Mercedes faced stiff competition from Tesla, which maintained a significant head start in the EV space thanks to its superior battery technology, over-the-air software updates, and expansive supercharger network. This forced traditional automakers like Mercedes to reassess and adapt their strategies. Compounding the challenge, Chinese EV manufacturers rapidly gained traction in the global market. In 2023, Mercedes-Benz sold its remaining 10% stake in Denza, a Chinese EV joint venture with BYD, after struggling to gain a foothold in the Chinese market. This highlighted the broader difficulty Western automakers faced as local brands like NIO, XPeng, and BYD surged in popularity with their affordable, high-tech EV offerings. Nonetheless, Mercedes remained committed to refining its electric vehicle strategy. Instead of competing directly with Tesla on price or software, the brand doubled down on its strengths: luxury, craftsmanship, and engineering excellence. Mercedes-Benz has long pursued the goal of delivering premium electric vehicles that embody top-tier comfort, high-quality materials, and advanced driver assistance systems. While the company has made commendable strides in electrification, it has also faced criticism for progressing at a slower pace compared to competitors like Tesla. Some industry analysts believe that Mercedes was initially hesitant to fully embrace electric vehicles, fearing that its traditional customer base, many of whom remain loyal to combustion engines, might resist the shift to electric mobility. In addition to this cautious approach, German automakers, including Mercedes, have encountered challenges related to battery efficiency and charging infrastructure. Tesla continues to hold a significant edge with its expansive and highly reliable supercharger network, which offers unmatched convenience and real-world usability. While Mercedes has partnered with charging providers such as Ionity to improve accessibility, it has yet to deliver the seamless user experience that Tesla customers enjoy. However, recent developments suggest there may be more to Mercedes' strategy than meets the eye. One clue lies in its latest engine release, the M139, a testament to the brand's engineering excellence. At the core of the M139's performance is its meticulously engineered design, featuring an aluminum alloy block and head that provide a lightweight yet robust structure. This contributes to a total engine weight of just 353 pounds, striking a balance between performance and efficiency. A standout design choice is the 180-degree rotation of the engine block compared to conventional layouts. This unique configuration places the intake system at the front and the turbocharger and exhaust manifold at the rear, near the firewall. The result is a shorter intake pathway, which enhances throttle response and overall efficiency, while also allowing for a more aerodynamically optimized front end. The M139 is equipped with a twin-scroll turbocharger that is both oil and water-cooled, effectively reducing turbo lag and delivering consistent power across the rev range. The use of roller bearings within the turbocharger further minimizes friction, enabling quicker spool-up times. To ensure optimal combustion efficiency, the engine also employs a two-stage fuel injection system, showcasing Mercedes' continued commitment to precision performance engineering, even as it navigates the evolving landscape of electric mobility. The M139 engine features a sophisticated injection system that combines direct fuel injection at pressures of up to 200 bar with port fuel injection operating at 6.7 bar. This dual injection approach ensures optimal fuel atomization and efficient combustion across the entire engine speed range. Upon its debut, the M139 was hailed as the most powerful production four-cylinder engine in the world. In its most potent S configuration, it produces an impressive 310 kilowatts at 6,750 rpm and a peak torque of 500 Nm between 5,000 and 5,250 rpm. This translates to an extraordinary specific output of approximately 208 horsepower per litre, figures typically associated with high-performance supercars. Such power enables vehicles equipped with the M139 to deliver rapid acceleration and an engaging, dynamic driving experience. The engine incorporates a range of cutting-edge technologies, including an electrically assisted turbocharger that significantly improves throttle response and virtually eliminates turbo lag, ensuring immediate power delivery. The turbocharger features a twin-scroll design that efficiently harnesses exhaust pulses to maximize both performance and efficiency. The valve train consists of dual overhead camshafts operating 4 valves per cylinder, providing precise control over valve timing and lift, which optimizes airflow and combustion. Larger exhaust valves further enhance the engine's breathing capabilities, contributing to its remarkable power output. To handle the thermal demands of high-performance driving, the M139 employs advanced cooling solutions, including an electric water pump that functions independently of engine speed to maintain consistent cooling under all conditions. This ensures optimal operating temperatures, boosting both performance and reliability. Altogether, the M139 marks a significant milestone in Mercedes-AMG's engineering achievements. But according to Mercedes CEO, the company has something even more revolutionary on the horizon. Hinting at a game-changing development, he boldly claimed, "Our new engine will destroy the EV industry. I've made my decision on how it should be built, and testing showed no indication that anything could go wrong. It's time to tell the truth." Mercedes-Benz is embarking on an ambitious strategy to reshape the automotive industry, surprising many with its decision to invest heavily in both combustion and electric vehicle technologies. By the end of 2027, the company plans to launch up to 19 new combustion engine models alongside 17 battery electric vehicles. A cornerstone of this approach is the development of the next-generation 4.0-liter twin-turbo V8 engine, which is expected to feature advanced electrification technologies, likely in the form of plug-in or mild hybrid systems. This integration aims to boost performance while preserving the iconic character of Mercedes V8 engines. While specific details remain under wraps, industry insiders speculate that this innovative powertrain could make its debut in models such as the upcoming CL63. This renewed focus on internal combustion engines is not simply a nostalgic gesture, it reflects a strategic response to current market conditions. Despite a global push toward electrification, consumer demand for electric vehicles has fallen short of expectations. Issues such as high upfront costs, limited charging infrastructure, and persistent range anxiety continue to hinder widespread EV adoption. By refining internal combustion engine (ICE) technology and integrating it with modern hybrid solutions, Mercedes-Benz seeks to offer a compelling alternative that blends traditional performance with improved efficiency and potentially disrupts an EV industry already grappling with challenges. To support this initiative, Mercedes is also undertaking significant cost-cutting measures and shifting production closer to key markets to mitigate the impact of trade tensions and tariffs. The company is targeting a 10% reduction in production costs by 2027, building on a prior goal of cutting costs by 20% between 2019 and 2025. One of the most persistent hurdles facing the EV sector is its struggle to match the reliability, convenience, and performance that combustion engines have honed over decades. With its next-gen V8 engine, Mercedes-Benz offers a best-of-both-worlds solution: high performance, better fuel economy, and hybrid capabilities that eliminate range anxiety, all without relying on the still-developing global charging infrastructure. Mercedes' new engine offers consumers the convenience of quick refueling while still incorporating advancements in electrification. However, insiders hint there may be more to this technology than the company has publicly disclosed. Some suggest Mercedes has been experimenting with ultra-efficient combustion techniques that could dramatically improve fuel economy, potentially making hybrids more practical than fully electric vehicles. Others claim the automaker has developed a groundbreaking energy recovery system that rivals the regenerative braking technology found in electric vehicles, further narrowing the efficiency gap. If these rumors are accurate, this new engine could delay the widespread adoption of EVs by several years. Automakers like Tesla and Rivian have already experienced slowing sales and growing concerns over profitability. Should Mercedes' strategy prove successful, other traditional manufacturers might follow suit, shifting focus back to combustion technology instead of pursuing full electrification. The real twist is that Mercedes has yet to reveal the full capabilities of this engine. Ultimately, this development could spark a significant ripple effect across the automotive industry, potentially forcing even EV-first brands to rethink their strategies.